This time we're going to be factoring polynomials with 4 terms using a method called factor by grouping. Here is an example of one of those polynomials. 15x cubed plus 25x squared plus 24x plus 40. Now the first step in factor by grouping, well, in all factoring really, is we want to check and see if there's a greatest common factor between all of those terms. And in this one there's not. So then we'll go on to what's really the first step of factor by grouping, and that is to split your polynomial into 2 groups. That's probably where they got the name, factor by grouping. And after we've split it into 2 groups, so I'll split it into 2 different groups, I'm going to factor the greatest common factor from the first group. So for the time being, I'm ignoring that second group. I'm just looking at the first group. I want to see what can go into 15x cubed and 25x squared. So that greatest common factor is going to be 5, and then both have x squared at least, so 5x squared. We go ahead and take that out. So 5x squared out in front, then divide out 5 from 15, we get 3. Divide x squared out of x cubed, we get an x left. And then divide 5 out of 25, we have 5. And then x squared into x squared, and there are no variables left. Next, we're going to look at that second group. So step 2, we're going to look at the second group, and we need to find a common factor from the second group so that you end up making, so you want to make the same binomial in parentheses as you had in the first group. I'll show you what I mean. So I'm looking at my first binomial of 3x plus 5. I need to take something out, something so that I have something times 3x plus 5. In looking at that group of 24x plus 40, it looks like I can take out an 8, and since that's a positive 8, I need to make sure that I write plus 8 times 3x plus 5. Now you may notice that I have a common set of parentheses. That binomial 3x plus 5 appears in 2 places. I'm going to use that in my next step. In step 3, I'm going to bring the common binomial out front, and that common binomial, so 3x plus 5 is going to go out front. So 3x plus 5 out front, and then that is going to be multiplied. So let's go and put common binomial out front. I'll put that in a parenthesis, and it's going to be multiplied by a second binomial made of the greatest common factors. So in my problem that I have up here, I've got 3x plus 5, that was my common binomial, and then my 5x squared plus 8 is my greatest common factors, so my second parenthesis will be 5x squared plus 8. So everything that was left in front of my parentheses goes in my second parenthesis. Now we should definitely check to see if this x squared, 5x squared plus 8 factors anymore, since it has an x squared in it. In this case it does not, so I will put a note down here that you should check to see if either set of parentheses will factor any further. And if it will, you should factor it. This one will not. I just wanted to point out also that you can check your answer by foiling. So let's go ahead and do that, just so you know on this problem that we're right. So we take first times first. 3x times 5x squared is 15x cubed. Outside times outside, plus 24x. Inside times inside, plus 25x squared. And last times last is plus 40. That's in a different order than our original problem was, which is all the way up there. But it's the same thing if we were to write this in standard form, which is decreasing exponents. So we have now factored our original polynomial, and that is the answer. We should probably do a couple more examples of these just to get some practice. So let's look at this one. How about 8p cubed minus 40p squared minus 24p plus 120. We want to check first if there's a greatest common factor before we even get started. It looks like everything is at least divisible by 2. Let's see, 8 and 40 are divisible by 8, so is 24. 120 is divisible by 8 as well, so it looks like 8 will come out of all 4 of those terms. So we'll start by doing 8 parenthesis, and then we have p cubed minus 5p squared minus 3p plus 15. And now we're ready to group. So again, we're going to start with splitting these into 2 groups. And we want to look for the greatest common factor just of that first pair. And it looks like it's going to be just 1p squared, or just p squared. So I'm going to keep my 8, and I'm going to put a square bracket around that so that I remember that it's times everything. So 8 times, and then I have p squared for my first group times p minus 5. And then remember, the trick for the second group is that I need to take something out so that I match the p minus 5. So what can I take out in front so that I have p minus 5 left back in there? And it looks like I need to take a negative 3, because negative 3 times p is negative 3p, and negative 3 times negative 5 is plus 15. So now I have that common binomial. My common binomial is p minus 5. So the p minus 5 will go together as one parenthesis, and then times the binomials that were left, so p squared minus 3. And I don't want to forget that I have that 8 from my greatest common factor out front. And then I'm going to check to see, does p squared minus 3 factor anymore? And it does not factor using integers, so for now the answer is going to be no. And then that will be our final answer that we could check by foiling and then distributing that 8. Now here is your first secret question. Secret question is one that you need to do on your own and bring in to have me look at and have us discuss. So you need to factor by grouping 6x cubed plus 42x squared minus 10x minus 70.